Sorry, welcome back to the class. A little bit mix up. Okay. See, today we're going to look at the concept, mole concepts, how to use the equation to solve some questions. Now, the first thing I need to do now, let me share my board and then to start working. And then we have the first thing we are going to look at. What is mole first? When you define the mole, from there you now look at how can you derive the equation to calculate mole. And I will be giving the equation that we are going to be using to calculate our mole. Hope you guys can see the board. Please, if you're in the class, let you signify yourself. Let me know to know the number of students I'm dealing with for today. Just send a message if you're in the class. And as I was saying, mole can be defined in following. And then the first equation we are going to give how mole is defined is mole equal to mass over molar mass. That is mass of substance over molecular mass. That is mole equal to mass over molecular mass of the substance. That's the first definition. And then the second definition we're going to also give is can also be defined, the same mole can also be defined as number of atoms over Avogadro constant. That is mole equal to number of atoms divided by Avogadro constant. And what is this Avogadro constant? Avogadro constant is given as 6.02 times 10 raised to the power 23. That is 1 Avogadro constant equal to 6.02 times 10 raised to the power 23 particle. Now, these are the two equations we're going to be working with to solve some questions. Now, let's look at the first question we're going to solve first. The first question here is given as calculate the number of mole of the following substance. 1, 31.6 gram of potassium tetraoxomanganate. That was the first question. While the second question is 1.6 gram of sulfur. 1.6 gram of sulfur. Now let's, first of all, what is this compound? Potassium tetraoxomanganate. I'll give you the molecular formula. That's the KMNO4. That's the molecular formula of potassium tetraoxomanganate. And then now the first thing, the formula we're going to use is mole equal to mass over molar mass. And then the first task we are going to look at after the equation, let's calculate the molecular mass of this compound. Remember, K equal to 39, Mn equal to 55, while oxygen equal to 16. Now let's multiply it together. Let's multiply it together first. By the time you input, that is 39 plus 55 plus 16 times 4. 16 times 4. What 16 times 4 is? 60 times 4 is 64. That means 64 plus 55 and then plus 39. What's the answer? Add it together. Add it together by yourself. That is 39 plus 55 plus 64. That is 39 plus 55 plus 64. And then the answer is 158. That means since the answer is 158, now take this mass now. 31.6, that will be 31.6 over 158. Oh yeah, divide it. That is 31.6 divided by 158. And then the answer is equal to 0.2. That means the answer here is equal to 0.2 mole. That's the answer we have. Let me explain it again. So the first thing that you need to do here is that I've already defined mole, that we have two equations first. And then the first equation is mole equal to mass over molar mass. And then the second one, mole equal to number of atoms over Avogadro constant. And then 1 over Avogadro constant equal to 6.02 times 10 raised to the power 23. Now we open the question first. I said the first question we have here is to calculate the number of mole of the following substance. What do you have here? We have 31.6 grams of potassium tetrahydromanganate and 1.6 grams of sulfur and 2.2 grams of phosphorus oxide. And then what you just need to do that and not solve the first question by the first thing, interpret the molecular formula of potassium tetrahydromanganate. And then this KMnO4, potassium is 39, manganese is 55, oxygen is 16, and then we have 4 atoms of oxygen here. 60 times 4. When you sum up everything together, we have 158, and then you put it back into the equation. That will be 31.6 158, which give you 0.2 mole. That is, when you take out 31.6 grams of potassium tetrahydromanganate, taking 0.2 mole out. Now, let's now look at the second question. How do you calculate the second question also? At least I'll show you how to calculate it. And I believe you can solve it by yourself. But let's solve it together before I'll now give you the question, the third question for you guys to solve. What's the second question? The second question is we have 1.6 grams of sulfur. Sulfur is an element with mass number 32. The mass number of sulfur is 32. Just apply mole equal to mass, which is 1.6 over 32, because mass number of sulfur is 32. Therefore, 1.6 divided by 32, 1.6 divided by 32, and then the answer is 0.05. Therefore, mole equal to 0.05 mole. That's the second question. Why the third question now? You take mass number of phosphorus multiplied by 4 and also oxygen multiplied by 4 and added together. That's how you get the molar mass of the oxide. And then when you divide, that is 2.20 divided by that mass number to give you the mole that contain there. And then let's now move to the next question. The next question is, how do you calculate mass from mole? That is just like the first question, but in this case, you are not looking for the mole, you are looking for the mass, whereby the mole is already given. Because here they say 0. No, let's look at the question first. Calculate in gram the mass of the following compound. And then the first one you have is 0.03 mole of oxygen. 0.03 mole of oxygen. Now, how do you calculate it? Remember, mole equal to mass over molar mass. Therefore, mass will be equal to mole times molar mass. This is the formula we are going to use. And then we have mole already, which is 0.03. That means 0.03 times molar mass of oxygen. Remember, oxygen exists at diatomic. That means one oxygen is 16, and then times 2. That will be equal to 32. That will just multiply 0.03 times 32. When you multiply 0.03 times 32, that is 0.03 times 32, and then you have 0.96. That means the mass here is equal to 0.96 gram. That's it. And then the second one is 0.06 of water. 0.06 of water. 0.06 of water. How do you calculate it? Let me clear the board first. Is 0.06 of water. Let me clear the board to make it clear very well. 0.06 of water. Remember, water is represented as H2O. And then let's calculate H2O. Hydrogen is 1. Hydrogen is 1. That will be 1 times 2 plus 16, which is equal to 18 gram per mole. 18 gram per mole. Therefore, mass equal to mole times molar mass, which is equal to 0.06 times 18. That is 0.06 times 18. When you multiply it, that's 0.06 times 18. That will be 1.08. That will be 1.08 gram of water. And then the third one is 0.95 mole of sodium hydrogen triisocarbonate. Sodium hydrogen triisocarbonate. Let's go back to that. The first, let me clear it first. And the first thing you need to do is that let's first of all interpret the molecular formula of this compound, hydrogen triazocarbonate. That be hydrogen triazo, sodium hydrogen triazocarbonate. That be NaHO3. That's the molecular formula of the compound. Now, the next step now is to calculate the molecular formula. Remember, sodium is 23. That be 23 plus hydrogen is 1 plus carbon is 12 plus oxygen is 16. That be 16 times 3. 16 times 3 is 48. Add 48 plus 23 plus 1 plus 12. What's the answer? Remember, 23 plus 1, that will be 24. 24 plus 12. 24 plus 12, that will be 36. And then the answer is 84 grams per mole. And then remember, mass is equal to mole times molar mass. Therefore, you are going to add 0.95 times 84 times 84. That is 0.95 times 84. That is 79.8 grams. That's how to calculate mass from mole when you are given the mole. And then the next concept we are going to look at, calculate the number of atoms. In this case, how do you calculate the number of atoms? By giving mass. The first thing you need to calculate first, you first calculate the mole. How do you calculate the mole? That is mole, remember, mole equal to mass over molar mass. Therefore, since you're already given the mass, that will be 0.72 divided by carbon. What the molar mass of carbon is 12. That will be 0.72. 0.72 divided by 12. That will be 0.06. That will be 0.06 mole. And then since you have your mole now, therefore, that's the number of particle or atom equal to mole times Avogadro's number. That means you have 0.06 times 6.02 times 10 to the power 23. Let me write it very well. 0.06 times 6.02 times 10 to the power 23. Now let's multiply 0.06 times 6.02. That be the answer now will be equal to 3.6 times 10 to the power 22. Okay. Thank you very much. Any question? If you have question, let me give you room. If you have question, let me know. You can, if you have your question, let me know. And if the question, if today's class is because of rain, let's stop for today's class. The next class we are going to take it up again. And if there's any suggestion that you can to improve, please let me know. I'm open for correction. Thank you very much. don't like this one.